Okay, so we're going to be looking at now still talking about domain and range, but looking at what happens when we have continuous graphs, like what we've been working on for the past couple days, but what happens when we have discrete data or discrete graphs, okay? So reminder, when I'm talking about continuous graphs, I mean that the line attaches all the points. So really, this line is just made up of many points all being attached together. And when you see a line, it is saying that every value between every point exists. So there's going to be points between each of these years, and there's going to be points between each of these heights. So you could be 69.2 inches. You could be in the year 1910 point something. Okay? Whereas discrete data, that's talking about data that cannot be connected between the points. So in an example like this is numbers of car parked at school. You see that we can say this is a number like 32, but we wouldn't be able to say that we had 32.6 cars because that's not a feasible amount of cars. We would need only whole values. So discrete data, you're going to find that you can't connect it with a line because you can't connect the data. The data does not allow for points to exist between the values, or not between all the values. Okay? So in saying that, let's see, between this scenario and this scenario, which one should have the points connected? So which data is continuous? So this is saying number of species over time. So number of species, I can't say I have 10.6 of a species. So in saying that, I could not suddenly create a point somewhere over here at 10.6. Okay? I also couldn't say that I have 24.7 and put a point there. So in saying that, I cannot connect these. I need an entire value of a species for this to be true. Whereas in Alice's graph, we have temperature, which can be represented with decimals. You can say I have 4.4 degrees, I have 10.8 degrees, and time that can also be represented with a decimal. So really, every value between these points could exist. And here's just a reminder, because we've been talking about what is a function throughout all of this, a reminder that when we're talking about doing that vertical line test, so drawing vertical lines down, that still is a method we can use when we're looking at discrete data. So I can look at this and create lines that pass through vertically. And if the line passes through the graph more than one time or passes through more than one point, more specifically like here and here, it is not a function. Whereas if I make vertical lines going down in this graph, every time I create that vertical line, it only ever passes once. So this would be a function. So let's see if now that we're looking at this discrete data, if we can now find the domain and range. And you may remember right at the beginning of this unit, we were looking at representing things sometimes graphically, sometimes in tables, and writing out the domain. So as soon as it's discrete and it's not attached by a line, we can't use that last method that we were just doing, like set notation and interval notation. So instead, we're going to have to list all of the domain values, so all of the x values. So one value would be 3 hours. 6 hours. We have 9, 12, 15. Oops, sorry. This is going to keep going. So we have 18, 21 hours, and 24 hours. And remember, we always open and close a set like this where we're listing with set notation brackets. In terms of the range or image, if you're in my French class, we're looking at all the y values this time. So 5, I can say this one is 6. Then we have maybe 11 and 12. And then I'll say 16. I'll say that's about 18. and 22. And again, I'm approximating for some of these values because they aren't as obvious, but I'm just reading the y value of each of these points. So for B, we would have to do the same thing. We'll identify which is the domain and then list all of the domain values, so all of the x values here. So again, in saying that, we're really just going to have to read this graph. So each value here is 5. So I'm going to go with 150, let's go with 158, 160, 162 maybe for that one, 165, 170. This one could be 174 maybe. Then we have 175 and 180. And then for the range, we listed all the y values. So let's go with 47, 51 for this point, maybe 53 for that one, 54, no, maybe 55 for that one, 57 for this point, 60, 62, 64, 68, and 70. And again, what you write may not be what I'm writing because, once again, we're approximating. The values aren't precise. So last up here, now can we just look at a situation and do everything that we've done in the unit so far? So first off, can we identify the dependent and independent? Just a reminder, independent are our x values. So in this case, that's our x-axis. It is time. So our dependent values are our y values, in this case, number of votes. So why are the points on the graph not connected? Well, number of votes versus time. Time can exist between all of these values, but number of votes, we can't say that we have a portion of a vote. So I'm going to write can't have a portion or fraction of a vote. Okay? Which means I could not suddenly connect these points and put a dot here and say suddenly that I have 23.7 votes. Okay? And then last up, can we determine the domain and range? So again, because we can't connect them, we can't use the method we've been working over the past 2 days. So we're just going to list the x values. So 9, 10, 11, 12, 13, 14, 15, and 16. For the range, it's going to be 6, 8, 10, 11, 15, and 25. And again, just make sure that you're identifying that here is the domain, here is the range, so that we're not mixing up what values you're trying to label. Okay? And that is it. So again, as soon as you see discrete data, so data that you cannot connect because you are not able to find values between the points that make sense given the problem, then you automatically list all the x values to identify the domain, and you list all the y values to identify the range.